Hello, good evening everyone. Welcome to BYJU'S exam prep. So in this special 26 series, we are actually discussing the 26 important topics with you from all the different subjects. So in the EMFT, this is the third session, and I am discussing the third topic, which is a rectangular waveguide. Actually, it is all over the chapter because there is a very less topic in the rectangular waveguide. So we cannot be very specific for the topic because all of you know that in the rectangular waveguide there are certain formulas, and based on that, definitely one or two problem will come. So that's why, based on that, I am discussing with the whole chapter with you. The whole chapter, that is the rectangular waveguide and circular waveguide. Okay. So just I want to share the session with all of you. So just we will go through it once. So just confirm me that whether I'm audible or not. Yes. So according to me, it is completely fine. So guys, before starting this session, I would like to tell about myself. So this is Saket Verma, and I'm having more than 13 years of experience in the field of GATE and ESC, and I have done MTech from IIT Guwahati, and I'm having also more than experience of mentoring more than lakhs of students. I have also mentored the different students, those who have cleared the PSU exams. And similarly, I have also cracked the PSUs like Airport Authority of India, DRDO, and Bharat Electronics Limited. And my area of expertise: electromagnetic theory, communication system, advanced communication system, signals and system, and ICT also for ESC. The Telegram group name, uh, this Telegram group name is this is the link of the Telegram group. Study with Saket Verma. The name of the group is Electronic by Saket Sir. And in this Telegram group, you will get the daily dose to improve concept, daily important questions, the latest information about the exams, for notification of the class, and also important PDFs you will get here. You can also clear the doubts by the expertise. Now, there is a very good news that we have produced the rank in the UPSC under 10, first rank in the civil engineering and the ninth rank in the mechanical engineering, and also few students got the under 50 rank, under 100 rank in the UPSC by the BYJU'S exam prep program. So before starting this, I would like to tell you about brief theory that is going to be the difference between the waveguide and the circular waveguide, or simply waveguide and the transmission line. So what are the difference? So waveguides are hollow metallic tubes used for the transmitting electromagnetic energy. Waveguides and transmission lines are two common methods of transmitting electromagnetic energy from source to load in a bounded medium. Okay, so waveguide and the transmission lines are two common methods of transmitting electromagnetic energy from source to load by the guided medium like a transmission line. And however, the waveguides differ from the transmission line in somehow aspects, that the transmission line can support only a TEM wave, whereas a waveguide can support many possible configurations like TE and TM mode. At microwave frequency 3 to 3300 gigahertz, transmission lines become inefficient because of dielectric losses, conduction losses, whereas in the waveguides are going to provide you with a higher bandwidth and the less attenuation in that range of the frequency. A transmission line may operate from DC, right? A DC means you can say the frequency is 0. So there is no cutoff in case of the transmission line. You can transmit any frequency. As you increase the frequency, the above losses will come into the picture. But when you when you talk about the waveguide operates above some certain frequency. So above the cutoff frequency, it will work, and below that frequency, it is not going to pass any signal. So the waveguide cannot transmit the DC, and they become excessively large at frequencies below microwave frequencies. So attenuation will be large, and it will be allowing the high frequency. So it is called as the high pass filter because it is allowing the frequency above some certain cutoff frequency. So we will also calculate the cutoff frequency for the rectangular waveguide, but there is no such type of frequency in when we talk about the transmission line. So the whole body of the waveguide acts as the ground, and the wave propagates through the multiple reflections in case of the waveguide. And there is a difference between the waveguide and the twin wire transmission line. In transmission line, cutoff frequency is 0, and it allows all the frequency to pass it. And the waveguide has the cutoff frequency known as the high pass filter. And wave propagation in waveguide is based on the electromagnetic theory concept, and the transmission line is more based on the network concept. Okay, and in waveguide we define the impedance, also known as intrinsic impedance, and in the transmission line we say about the characteristic impedance. Now, in the rectangular waveguide, the boundaries are made up of perfect conductor, and the dielectric, which we will also consider as a perfect dielectric. So there is no loss, so no lossless dielectric we feel, and the boundaries are perfect conductor. Because of the perfect conductor, the field at the boundary, the electric field will be 0. So the electric field, tangential component of electric field at the boundary should also be 0 inside. Means exactly at the boundary both should be matched. Boundary condition should be matched. The boundaries are x equal to 0 and a, y equal to 0 and b. And in the standard waveguide, the one dimension a is greater than b. Okay, the broader dimension is known as a, and we also calculate the aspect ratio, that is known as a by b. Okay. Hello Chinmay, good evening. So then we have certain equations in the rectangular waveguide, because when we talk about the waveguides, we have certain number of modes like TE and TM mode. So based on that, certain field will be 0 in the certain direction that we will discuss. But to calculate the field component in the other direction, like electric field component in the x and y direction, magnetic field component in the x and y direction, how can you do that? So Ex is equal to minus gamma upon h square del Ez, if electric field z component upon del x, minus j omega mu upon h square del hz upon del y. Ey is equal to minus gamma square del Ez upon del y plus j omega mu upon h square del hz upon del x. Hx is equal to minus gamma upon h square del hz upon del x plus j omega epsilon upon h square del Ez upon del y. And hy is equal to minus gamma upon h square del hz upon del y minus j omega epsilon upon h square del Ez upon del x, where this h square is known as the transverse propagation constant, which is equal to gamma square plus omega square mu epsilon, which is also equal to kx square plus ky square. So based on this electric field, we say that any configuration, either T or Tm, of electric field and magnetic field must be a solution of Maxwell equation. Beside this, field must also satisfy the boundary condition imposed by the wall of the waveguide. There can be no tangential component of electric field at the wall of the waveguide if wave walls are perfect conductor. So there are different field configurations that need their requirements according, and such configuration are called modes. So every field equation has to satisfy the Maxwell equation, and apart from the Maxwell equation, they has to satisfy the boundary condition as well. There should not be any tangential component, because the other side of the boundary is perfect conductor. So the no electric field will exist tangential component at the boundary, that is known as the boundary condition. So based on this different field configuration and the requirement, we have a different configuration called as mode. Now, as I told you that there are certain number of mode like TE, TM and TEM mode, but TEM mode is mode, in this mode we have the electric field and magnetic field always perpendicular to the direction of propagation. So if the wave is traveling in the z direction, then the electric field and magnetic field will not exist in the direction of z. So Ez and Hz will be 0. So if I put Ez and Hz 0, Ez, Hz 0, Ez, Hz 0, Ez, Hz 0, Ez or Hz 0, then all the field components will go 0. That means there are no field components. So electric field and magnetic field both are 0 along the direction of propagation. Hence the TEM mode cannot exist in a waveguide. In a waveguide, all the field components will go 0 if Ez and Hz will be 0. Second, the transverse electric mode, as the name suggests, that the electric field will exist only in the perpendicular to the direction of propagation. So electric field will not exist in the direction of propagation. So if the wave is traveling in the z direction, then electric field will not exist in the direction of z, and Hz is not equal to 0. In this mode, electric field in the direction of propagation is 0, but the magnetic field is not 0. This mode is also called as H-plane mode. Okay, this mode is also called as H-plane mode. Similarly, the transverse magnetic mode, the field in the direction, magnetic field will not exist in the direction of propagation. That means the field will exist in the direction perpendicular. That is, if the wave is studying the z direction, then the magnetic field will exist in the perpendicular to the z. So it will exist in the z direction, Hz equal to 0 and Ez is not equal to 0. Now there are certain points about this. The transverse electric and transverse magnetic modes are commonly referred to as the waveguide modes, since there are only modes which exist in the enclosed guided structure. So these are the two modes that can exist in the waveguides, because TEM mode cannot exist. TEM mode cannot exist because of the single conduct guiding structure, and TEM mode is characterized by the cutoff frequency. It will not allow the frequency below the cutoff frequency. TE and TM mode can exist on the transmission line but are generally undesirable. TM modes are sometimes called as the transmission line modes. They are called as dominant modes. Transmission lines are typically operated at the frequency below the cutoff frequency of TE and TM mode, so that TM mode exists. Quasi-TM modes are modes which approximate the true TM mode when the frequency is sufficiently small. The mode having the lowest cutoff frequency is called the dominant mode, or having the highest wavelength. Okay, the field component in the case of TM mode. So as the TM mode, the direction of magnetic field, the Z component of magnetic field will not exist in the direction of propagation. So the electric field will exist. So electric field will be in the form of this. Okay, this you have to remember, that Ez will be E naught sine m pi by ax and sine m pi by by. For a TM mode rectangular waveguide, m and n cannot be 0, neither m nor n, because if any one of these will be 0, the Ez will be 0 and Hz is already 0, so it will become TM mode, which will not exist in the rectangular waveguide. What are the possible mode in the TM? TM mode will have the lowest cutoff frequency, which is TM11. M is half wave, number of half sinusoidal cycle variation along the x-axis, number of half sinusoidal variation along the y-axis, right? Now, what are the TE mode field equations? So in the TE mode, H will be existing and the direction of propagation, and that will be in the form of H naught cos n pi by ax and n pi by by. The lowest mode possible is TE10, because any one of these will be 0. And then m and n both will be 0, then H naught will become, which will be a DC signal which will not pass. So hello Venugopal, hello Ankit. So the field equation in case of TE mode is H naught cos n pi by ax, and the minimum mode that can exist is TE10, because A is greater than B. If A is not greater than B, then obviously the TE01 mode will be existing as a dominant mode, but obviously whatever will be the higher dimension, we will take that as the A. So for us, TE10 will be a dominant mode. And for a rectangular waveguide, these certain parameters that you should know, that frequency which is less than the cutoff frequency, that is not passed through the waveguide, and that means the gamma will be 0. So alpha and beta both will be 0. So that will not allow propagation. So propagation is not there in case of gamma 0. Okay, gamma 0, no propagation. When the frequency, operating frequency is greater than the cutoff frequency, you will get alpha 0 and non-zero beta, which is known as guided phase constant, and the propagation happens. And when omega is equal to omega c, again it will be alpha and beta both 0, no propagation will occur. What are the different formulas? So guided phase constant beta g is equal to beta root over 1 minus fc upon f whole square, and the cutoff frequency is fc is equal to vp upon 2 root over m by a whole square plus n by b whole square. Cutoff wavelength is lambda c is equal to 2 upon root over m by a whole square plus n by b whole square. Guided wavelength is 2 pi by beta g lambda upon root over 1 minus fc upon f whole square. And epsilon r is equal to c square upon omega square in the bracket beta g square plus m pi by a whole square plus n pi by b whole square. So these all are the formula. Is it clear to everyone? Yes, Vishwajit, no issue. Now, guided phase velocity, the phase velocity inside a waveguide, which is defined as the velocity with which a particular phase propagates, is known as phase velocity. And when the group of frequency propagates through the waveguide, that is known as the group velocity, which is delta omega by delta beta g, which is Vp root over 1 minus Fc upon F whole square. Yes, Vishwajit, definitely. If you remember all these formula which I mentioned here, and we will also solve the problems right now. Just after this formula, then you will be able to solve the questions of the waveguide. 90% chance is there that you will be able to solve the questions of a rectangular waveguide, because there is no very twisted question comes in the waveguide. There directly formula based question comes, so that will be, I think, sufficient. If you just know the certain things about the dominant mode, what is the next higher mode we call, like dominant mode is the mode in which we have minimum cutoff frequency. So that will give you the minimum cutoff frequency. So there are more modes which will give just above the cutoff frequency, like minimum cut, just more than the minimum cutoff frequency. So just more than the minimum cutoff frequency will be your next higher mode, and then just above the cutoff frequency will be then higher mode. Like that you have to calculate the modes, right? So if you calculate these modes, you know the sequence of the modes, then also it is efficient. I will tell you the way we will solve the questions. So intrinsic impedance also for both the mode you should remember, like for eta TM. For TM mode, if you calculate the intrinsic impedance, it is eta root over 1 minus Fc upon F whole square. Okay, and eta divided by root over 1 minus Fc upon F whole square. These are the two formulas of the wave impedance. Yes. Now try to answer this question. 1.5. Okay, yes, 1.5 gigahertz. So actually, I was not able to see the chat, so I was refreshing that. Yes. So now you are getting 1.5 because as you can see that this is the air field. So we have a cutoff frequency formula. Fc is equal to Vp upon 2 root over, okay, root over m by a whole square plus n by b whole square. And if nothing is given, then we have to consider the dominant mode. Dominant mode means TE10 mode is the dominant mode for all the modes, right? TE mode or TM mode, both we will consider. Then the dominant mode will be TE10 mode. The EDC analog will also happen, Anant. Just after me means I think from Monday onwards it will start. Okay, from Monday onwards it will start, and phase velocity will become velocity of light because of the air field. So 3 into 10 to the power 10 centimeter per second, and a is whatever will be the higher dimension, we will take it as a. So it is nothing but a 30 upon 20, so 1.5 gigahertz, right? So this is the next question. Solve this question, Vishwajit. I have told you formula, Vishwajit. So if you are watching and if you have noted down all the formulas, then try to solve it. यस, कम्युनिकेशन का क्लास जो होगा अनंत, वो ना 24th या 21st से, कम्युनिकेशन का 21st से है। तो उसमें भी हम लोग मैच फिल्टर डिजिटल कम्युनिकेशन से ही स्टार्ट करेंगे, सो दैट क्योंकि स्टार्टिंग में स्टूडेंट्स का थोड़ा इंटरेस्ट रहता है, फिर बाद में नहीं आते हैं, तो एटलीस्ट स्टार्टिंग के 2 क्लासेस में अपन डिजिटल कम्युनिकेशन का पार्ट कवर कर लेंगे। सो ईटा टीई मोड के लिए अगर हम देखोगे तो ईटा रूट ओवर 1 माइनस एफ सी अपॉन एफ का होल स्क्वायर है। सो 377 डिवाइडेड बाय रूट ओवर, आपको एफ सी निकालना पड़ेगा, ठीक है? तो एफ सी निकाल लो, तो एफ सी आ जाएगा T20 मोड के लिए है तो C अपॉन 2 यही आएगा, और फिर यहाँ से m बाई ए से 2 बाई ए आ जाएगा, तो 2 और 2 कैंसिल हो गया, C बाई ए आएगा। सो 3 into 10 to the power 10 and A is, what is the value of A? Higher dimension 3. So 3 centimeter में है, so this is nothing but a 10 gigahertz. So cutoff frequency is 10 gigahertz, operating frequency is 30 and whole square. What will be the answer? 400 ohm. Okay. So 400 ohm is the right answer. Next. Try answering this question. Yes. Try answering this question. For a rectangular waveguide of internal dimension A cross B, A is greater than B. The cutoff frequency for TE11 mode is the arithmetic mean of the cutoff frequency for TE10 mode and TE20 mode. If A is equal to root 5, then the value of B is. Okay, see here it is given that TE11 mode is the arithmetic mean. So FC TE11 is FC TE10 plus FC TE20 divided by 2. That is the meaning of this, right? And 0.75 you are getting. Okay, let's check. So this TE11 mode means VP upon 2. Okay, and root over 1 by A whole square plus 1 by B whole square, and VP upon 2. Okay, 1 by A, right, and plus Vp upon 2 TE20, so this is 2 by A divided by 2. Okay, so Vp by 2 will get cancelled, Vp by 2 will get cancelled, and here we will get 3 upon 2A, right, and if I square it I will get 1 upon A square plus 1 upon B square, and this is square. So 1 upon A square means 5, 1 upon B square plus 9 upon equal to 9 upon 5. So B square is equal to 1 upon B square equal to, so 1 upon B square is equal to 9 by 20 minus 1 by 5. So how much it is? The LCM will be 29 minus 4. So 5 by 20 is equal to 1 upon b square. So b is equal to 2. B will be 2. B will be 2. Okay. The value of b would be 2. Right? Check your answers. Okay, geometric mean नहीं लेते, arithmetic mean. Okay, arithmetic mean लेना है. Now try answer this question. Solve this question. You are getting TE to 1. Okay. So because if you compare, it is the HZ and the longitudinal direction means the in the direction of propagation. So you are having the Z component of magnetic field means the electric field will be 0. So electric field will be 0. That means it will be definitely a TE mode. So that is confirmed that it is a TE mode. So TM mode option will not be there. Now we will compare this. So this m pi by a is equal to 25 into pi. So pi and pi will get cancelled and m is equal to 25 into a, which is 0.08. So this is 2. And similarly n pi by b is equal to 30.3 pi. So this pi and pi will get cancelled and n is equal to 30.3 into b. B is 0.033. So after solving this, we will get 1. So we will get M is equal to 2 and N equal to 1. So TE21 mode. Right. So guys, so there is a very important scholarship test on this Sunday tomorrow from 9 a.m. to 9 p.m. If you are preparing for Gate 25, then you can be a part of BYJU'S family by just appear on in this scholarship test. You can get the maximum discount up to 90%. There is a workshop also on Monday 20th at 7:30 p.m. by the madam, and in the ideal strategy to become a topper in the 2025. So now try answering this question. Options you might not be able to see, so I'm hiding myself for 2 minutes. Just please answer this question. See, according to this question, the standard air-filled rectangular waveguide of dimension A is equal to 2.29 and B is equal to 1.02 centimeter are designed for the radar application. It is desired that these waveguides operate only in the dominant mode TE10 mode with operating frequency at least 25% above the cutoff frequency of the TE10 mode, but not higher than the 95% of the next cutoff frequency. So what is the next cutoff frequency? So remember that whenever the A is greater than 2B, okay, whenever the A is greater than 2B, the modes sequence are TE10 and then next mode will be TE20, then next mode will be TE01 and like that. Okay, TE11. Like this will be the sequence of the mode. First mode, second mode, third mode, fourth mode and so on. Okay, so the first cutoff frequency, that minimum cutoff frequency will be always for the dominant mode. So the operating frequency should be at least 25% above than the cutoff frequency. So the operating frequency will be in the range of 25% above the cutoff frequency. So cutoff frequency TE10 plus 25%. So 0.25 of FC TE10. Then the next higher mode 95%. So 0.95 times of next higher mode, that is FC TE20. So it is 1.25 times of FC TE10 and F 95% means 0.95 times of FCTE20. What is TE10 for airfield? It is C upon 2A, and F 0.95 up into C upon A. So 1.25 into 3 into 10 to the power 10 divided by 2 into A. A is 2.29. 0.95 into 3 into 10 raised to power 10 divided by A means 2.29. You should cover EMFT and both communication both actually. If you want to get good score, then you should cover both. But if you have the choice of any one, then I will suggest EMFT, because that is more based on formula. So there is a chance that you will get a formula based question. So it is 8.18 gigahertz, and it is 12.45 gigahertz. So 8.18 to 12.45. So that is your option number B. Option number B will be the right answer for this. Who has got the answer? Next, higher mode, let me tell you that what is the cutoff frequency. First of all, let's write the formula. Okay, अनंत आप इसको देखो ध्यान से. FC का फॉर्मूला देख लेते हैं. VP अपॉन 2 रूट ओवर m बाई a होल स्क्वायर प्लस n बाई b होल स्क्वायर. ठीक है, ये फॉर्मूला होता है. अब जैसे कि मान लो डोमिनेंट मोड है तो TE10, ये तो कंफर्म है कि डोमिनेंट मोड है, TE10 ही होगा. तो TE10 के लिए कट ऑफ फ्रीक्वेंसी आ गया VP बाई 2 इंटू ए, डिनोमिनेटर में VP अपॉन 2A, इसमें कोई डाउट नहीं. अब TE20 लिखो. TE20 लिखोगे तो कितना आ जाएगा कट ऑफ फ्रीक्वेंसी? तो VP अपॉन A आ गया. ठीक है. अब अगर आपको डाउट है कि TE10 के बाद 01 आना चाहिए, तो देखो 01 का क्या लिखोगे? 01 का कट ऑफ फ्रीक्वेंसी लिखोगे VP अपॉन B, 2B लिखोगे ना कट ऑफ फ्रीक्वेंसी. अब आप इन तीनों को कंपेयर करो. हम लोगों को जो डेटा गिवन है, एक स्टैंडर्ड रेक्टेंगुलर वेवगाइड में A की वैल्यू हमेशा 2B से बड़ी होनी चाहिए. ये मोस्टली स्टैंडर्ड वेवगाइड में होता ही है. ठीक है, नहीं भी होगा तो A की वैल्यू ग्रेटर देन B होगी, लेकिन इस क्वेश्चन में A की वैल्यू ग्रेटर देन 2B है. तो इस चीज को फोकस करो. अब देखो A की वैल्यू ग्रेटर देन 2B है, और ये इस पहले वाले केस में देखो तो A की वैल्यू ग्रेटर देन 2B है और उसमें डिवाइड बाय 2B है, तो कट ऑफ फ्रीक्वेंसी सबसे कम आएगा. अब ये जो A है ये 2B से बड़ा है. A का वैल्यू 2B से बड़ा है, तो इन दोनों में कौन सा वैल्यू कट ऑफ फ्रीक्वेंसी कम देगा? मिनिमम कट, लेस कट ऑफ फ्रीक्वेंसी किस केस में मिलेगा? लेस कट ऑफ फ्रीक्वेंसी आपको TE20 में मिलेगा देन द TE01. ठीक है, लेस कट ऑफ फ्रीक्वेंसी आपको किस में मिलेगा? TE20 में मिलेगा, बिकॉज A की वैल्यू 2B से बड़ी है इस क्वेश्चन में. अगर A की वैल्यू एग्जैक्टली इक्वल टू 2B होता तो TE20 या TE21 दोनों में से कोई भी आप ले सकते थे. ठीक है, दोनों में से आप कोई भी लेते फर्क नहीं पड़ता. बट क्योंकि TE20 इसलिए आएगा बिकॉज A की वैल्यू ग्रेटर देन 2B है. अब बताओ, आप समझ में आया? चलो ये वाला क्वेश्चन सॉल्व करो. फर्स्ट पार्ट तो आगे होगा, तो आई होप दैट यू हैव गॉट द फर्स्ट पार्ट। फर्स्ट का भी ये नॉन मैग्नेटिक ही लेना है आपको, बाय डिफॉल्ट नॉन मैग्नेटिक ही लेना है, अगर नहीं गिवन है तो बाय डिफॉल्ट नॉन मैग्नेटिक ही लेना है। सो एम पाई बाई ए इक्वल टू 40 पाई आपने किया, पाई और पाई कैंसिल हो गया, एम इज इक्वल टू 40 ए। सो ए कितना है 5 है ना, तो 40 इंटू 5 हो गया 2, तो यहां से आ जाएगा 2। ठीक है, एंड एन पाई बाई बी इज इक्वल टू योर 100 पाई। सो पाई एंड पाई विल गेट कैंसल, एन इज इक्वल टू 100 बी, यहां से आ जाएगा 3। सो 2 3, ये आंसर हो गया। एप्सिलॉन आर कैसे निकालेंगे? एप्सिलॉन आर निकालने के लिए जो अभी आपको फॉर्मूला बताया, तो उस फॉर्मूला को आप सी स्क्वायर अपॉन ओमेगा स्क्वायर रूट के अंदर बीजी स्क्वायर प्लस एम पाई बाई ए का होल स्क्वायर प्लस एन पाई बाई बी का होल स्क्वायर। ठीक है, सो फॉर्मूला क्या था हमारा, एप्सिलॉन आर इज इक्वल टू सी स्क्वायर अपॉन ओमेगा स्क्वायर इन ब्रैकेट बीटा जी स्क्वायर प्लस एम पाई बाई ए का होल स्क्वायर प्लस एन पाई बाई बी का होल स्क्वायर। ठीक है, ये सी है तो सी मतलब 3 इंटू 10⁻8 का होल स्क्वायर कर लो। ओमेगा स्क्वायर है तो यहाँ पे ओमेगा 2.4 पाई इंटू 10⁻10 है, 2.4 इंटू पाई इंटू 10⁻10 का होल स्क्वायर। बीटा जी कितना है 52.9 पाई, सो 52.9 पाई का होल स्क्वायर। एम पाई बाई ए कितना है 40 पाई, और 40 पाई का स्क्वायर हो गया, और एक है 100 पाई, तो 100 पाई का स्क्वायर कर लो। तो सब में आपका पाई कैंसिल हो गया, तो ये आ गया 9 इंटू 10⁻16 डिवाइडेड बाय 2.4 इंटू 10⁻10 का होल स्क्वायर। ठीक है, तो ये आ गया 52.9 का होल स्क्वायर प्लस 40 का स्क्वायर प्लस 100 का स्क्वायर। इसको सॉल्व करके बताओ कितना आ रहा है। 2.25 आ रहा है, सो आफ्टर सॉल्विंग दिस 2.25 आ रहा है। सही है, तो ये आपको फॉर्मूला याद रखना है। अगर आपको परमिटिविटी पूछेगा, देखो अभी तक कभी भी परमिटिविटी क्वेश्चन में नहीं पूछा है एग्जाम में, तो ये एक अच्छा क्वेश्चन है आपके लिए, जहाँ पे आपको एप्सिलॉन आर निकालने पूछा जा सकता है। आप डायरेक्ट फॉर्मूला याद रखो, घूम फिर के आपको बीटा जी का फॉर्मूला ही लगाना है, बीटा जी के फॉर्मूले से ही निकाला हूं मैं इसको, है ना। तो लेकिन आपको क्या करना है कि आपको थोड़ा सा सिंप्लीफाइड फॉर्म में लिख लेना है, तो आपका काम आसान हो जाएगा। ठीक है, ये एक्चुअली इसी फॉर्म से निकला है बीटा जी, यहाँ से हमारे पास ओमेगा बाय सी आएगा। ठीक है, और अगर मीडियम है ना, जैसे कि मीडियम नॉन मैग्नेटिक मीडियम है, बीटा की वैल्यू म्यू आर इंटू एप्सिलॉन आर आएगा, फिर यहाँ से होल स्क्वायर, यहीं से इस फॉर्मूले को डिराइव किया हूँ। ठीक है, तो यहाँ से आप जाओगे तो ये आ जाएगा सी इंटू बीटा जी अपॉन ओमेगा। ठीक है, यहाँ से हमारे पास रूट ओवर म्यू आर और एप्सिलॉन आर आ गया। ठीक, और ये पूरा रूट ओवर 1 माइनस एफ सी अपॉन एफ का होल स्क्वायर। तो म्यू आर की वैल्यू तो 1 हो गई, तो रूट ओवर एप्सिलॉन आर का वैल्यू कितना आ गया c इंटू बीटा जी अपॉन ओमेगा, और ये डिवाइड में 1 माइनस एफ सी अपॉन एफ का होल स्क्वायर। फिर ये पूरे को स्क्वायर करोगे तो यहाँ से सी स्क्वायर बीटा जी स्क्वायर अपॉन ओमेगा स्क्वायर, और डिवाइड में 1 माइनस एफ सी अपॉन एफ का होल स्क्वायर। तो यहीं से ही घूम फिर के मैंने निकाला है, बट इसको मैंने इस फॉर्म में लिख लिया है जिससे हमारा काम थोड़ा ज्यादा आसान हो जाएगा। ठीक है, समझ में आ गया? चलो ये वाला क्वेश्चन सॉल्व करो। देखो सिंगल मोड का क्या मतलब है कि सिंगल मोड में आपको ऑपरेट कराना है, मतलब मिनिमम एक ही मोड में ऑपरेट होना चाहिए। तो एक ही मोड में कौन से मोड में ऑपरेट हो सकता है? अगर आपको सिर्फ एक ही मोड में ऑपरेट कराना है तो कौन से मोड में ऑपरेट हो सकता है? वेव गाइड। अगर आपको एक ही मोड में ऑपरेट कराना है तो कौन से मोड में हो सकता है ये ऑपरेट? यस, तो डोमिनेट मोड में ही ऑपरेट हो सकता है। तो आपका जो ऑपरेटिंग फ्रीक्वेंसी है वो किससे ग्रेटर होना चाहिए? डोमिनेट मोड के जो कट ऑफ फ्रीक्वेंसी है उससे ग्रेटर होना चाहिए। और किससे लेस होना चाहिए? तो जो नेक्स्ट हायर मोड है उससे लेस होना चाहिए। ठीक है, तो एक ही मोड में ऑपरेट कराने के लिए मिनिमम कट ऑफ फ्रीक्वेंसी तो होना ही चाहिए। तो ऑपरेटिंग फ्रीक्वेंसी जो मिनिमम कट ऑफ फ्रीक्वेंसी है उससे ज्यादा होनी चाहिए, और जो नेक्स्ट मोड है उसकी कट ऑफ फ्रीक्वेंसी से कम होना चाहिए, ताकि उस मोड पे वो वर्क ना कर सके और डोमिनेट मोड पे वर्क कर सके। एक मोड में ऑपरेट कराने का क्या मतलब है कि डोमिनेट मोड में वर्क कराना है। तो डोमिनेट मोड में वर्क कराने के लिए ऑपरेटिंग फ्रीक्वेंसी को कट ऑफ फ्रीक्वेंसी फॉर द डोमिनेट मोड से ज्यादा होना चाहिए, है ना। और जो नेक्स्ट हायर कट ऑफ फ्रीक्वेंसी आने वाला है उससे कम होना चाहिए, क्योंकि अगर आपका ऑपरेटिंग फ्रीक्वेंसी नेक्स्ट हायर मोड के कट ऑफ फ्रीक्वेंसी से ज्यादा हो गया तो वो उस मोड को भी सपोर्ट करेगा, तो फिर तो दो मोड हो जाएंगे। तो हमारे पास एक ही मोड आना चाहिए, तो एक मोड आने के लिए ऑपरेटिंग फ्रीक्वेंसी को सिर्फ कट ऑफ फ्रीक्वेंसी से ज्यादा होना चाहिए। तो इसका वैल्यू तो आपका ए और बी का सेम है जो हम लोगों ने वाला क्वेश्चन किया था, तो इसका आंसर आ जाएगा ऑप्शन नंबर बी। ठीक है आनंद, क्लियर है ये? तो ये वाला क्वेश्चन मैं आपके लिए एज अ होमवर्क दे रहा हूँ। ठीक है, बाकी फिर हम लोग नेक्स्ट क्लास यानी कि एंटीना वाली क्लास में मिलते हैं। सर्कुलर वेवगाइड के लिए हमारे पास सफिशिएंट टाइम नहीं बचा। 8 o'clock को अभी मेरा मल्टी सब्जेक्ट टेस्ट है ना। मल्टी सब्जेक्ट टेस्ट आपको मिल जाएगा। मल्टी सब्जेक्ट यानी कि मिक्स सब्जेक्ट टेस्ट आपका होगा अभी जस्ट 8 o'clock को ऐप में। तो आप बायजूस एग्जाम प्रेप का ऐप जो है वो डाउनलोड कर लो, डिस्क्रिप्शन में आपको ऐप दिया हुआ है। ठीक है, और ये हम लोगों ने 25 और 26 का बैच ऑलरेडी लॉन्च कर रखा है, तो आप इस बैच के पार्ट बन सकते हो। ठीक है, और ये आप मेरा टेलीग्राम ग्रुप ज्वाइन कर सकते हो फॉर मोर डिटेल। एंड क्लास का लिंक जो अभी जो क्लास होगी 8 PM को, उसके लिंक के लिए आप ये बायजूस एग्जाम प्रेप ऐप डाउनलोड कर लो, और इस क्लास का लिंक आपको इस टेलीग्राम ग्रुप में मिल जाएगा। ओके, चलो। सो थैंक यू फॉर वॉचिंग दिस सेशन गाइज, एंड हम लोग मिलते हैं नेक्स्ट क्लास में। नेक्स्ट क्लास हमारा होगा कल शाम को 8:30 बजे, है ना। टुमारो 8:30 PM को हमारी एंटीना की क्लास है। तो उसमें भी हम लोग कुछ क्वेश्चन सॉल्व करेंगे, सारे जो इंपॉर्टेंट क्वेश्चन है जिससे आपके कंसेप्ट ब्रश अप हो पाए, और जो इतने भी इंपॉर्टेंट टॉपिक्स होंगे। ओके, थैंक यू। हेलो हेलो।